Today we're reviewing some things that we need to remember and know before the map test. So this is all actually a review, but we're just going to go over a few things. First up is rational and irrational numbers. On the left, you'll see a bunch of examples of rational numbers. These are like normal numbers. They're not crazy. They usually have patterns. They're predictable. And then on the right, we have irrational numbers, which are crazy. They go on forever. They never repeat. They're random. It's like me versus Miss Weinstein. I am pretty irrational. Miss Weinstein is very calm, cool, collected. Miss Weinstein is rational. And so when we think about rational numbers, the formal definition is a number that can be written as a fraction. So that includes things like you see up here, whole numbers, integers, positive or negative whole numbers, decimals that stop, if it repeats. So these are all things that are like predictable, right? If it's a square root with an answer, with a whole number. These are all things that you would expect. So like for the square roots, this answer up here would be square root of 9 is 3. So it would be 3 on top. Square root of 4 is 2. So that's 3/2. So it has an answer. It's a whole number. Or it has whole numbers on the top and bottom, which makes a fraction. And so an irrational number is crazy. The formal definition is a number that goes on forever and never repeats. We see some examples of that up top. If it's a square root that's not a perfect square, it's going to be irrational. Anything with pi in it, pi is going to be irrational. If you have a decimal that is just random like this, even though this one does have a pattern, it looks like it's not repeating, like 77777. That's what I mean by repeat. The first example says to select 3 rational numbers. Okay, this first one is a fraction. Well, things that can be written as fractions are rational. The next one, I would have to do power to a power. So I'm going to multiply the 2 to the 1 and the other one. So it's going to be 5 squared over 9 squared, which is 25 over 81. Well, that's a fraction, so yes, it's rational. The next one is the square root of 8, which is not a perfect square. And so I know right away that that's a no. Because if I type it in my calculator, I would get something crazy that goes on forever and never repeats. The next one, it's still got square root of 8, but it's the square root of 8 squared. Now in this class, we talked about how square roots and squares are opposites, and so these will actually cancel each other out, just like we would in an equation, and we're left with 8. So that is a rational number, it's a whole number. The last two have pi, so that's a no. Now we're going to talk about a few symbols, congruent, equal, and similar. This first one, the one squiggly line with an equals, is congruent. And the technical definition for that is that they have the same angles and side lengths, same angles and the same side lengths. In this class, we talked about 2 things will definitely look congruent if they're the same size and the same shape. Okay, I'm going to draw a line down. Next is equal. That should be one you're familiar with. Means that it's same in measure if we're talking about shapes. And then lastly, similar. They have the same angles but different side lengths. and it's going to look like they're the same shape, but they are going to be different sizes. Now we're going to talk about what each of these actually say. So with the symbols, this says, the first one says that angle A is congruent to angle B. That little looks like an inequality sign is actually an angle sign. Next, this one says that the measure, that's what the M stands for, is measure, of angle A is equal to the measure of angle B. Moving right along. These two actually describe line segments. So the points at either end are A and B, or C and D. So this says that line segment AB is, and that's the congruent symbol, congruent to line segment CD. The last is that was one squiggly line, which means similar. So this is actually a quadrilateral because it has 1, 2, 3, 4 points. So quadrilateral A, B, C, D is similar to quadrilateral G, H, I, J. This next one is about scientific notation. So it says the distance around a track is 1.584 times 10 to the 4th inches. In scientific notation, what is the distance of a mile on the track? So I know that, and hopefully you guys do too, that 1 mile is 4 laps around a track. So if I write this out, 1.584 times 10 to the 4th, the first thing I'm going to do is move it out of scientific notation. So this tells me to go to the right because it's positive. 1, 2, 3, 4. We'll fill that empty spot with a 0. So I'm going to write it out again. And I'm doing 4 laps around a track. So I'm going to multiply this by 4. Remember we multiply, so 4 times 0 is 0. 4 times 4 is 16, carry the 1. 8, 4 times 8 is 32, add the 1, so 33. 4 times 5 is 20, add the 3, so 23. Carry the 2, and 4 times 1 is 4, plus 2 is 6. So I get 6, 3, 3, 6, 0 inches, and now I'm going to move the decimal back so the number's between 1 and 10 and write it in scientific notation. So I moved it 1, 2, 3, 4 times, so times 10 to the 4th. Last example, we got to decide where these numbers fall between what two whole numbers. So we're going to do one at a time. Square root of 7. Okay, well I know that's between the perfect squares, 4 and 9. Square root of 4 is 2, square root of 9 is 3. So my answer would be between 2 and 3. So let's go ahead and put that in the box. So square root of 7. Next one. We've seen something like this before. Square root and the square cancel out, so you're left with 2.5. So it is between 2 and 3. Let's label it. Square root of 2.5 squared. Next one, pi divided by 3. So on this portion of the map test, you can't use a calculator. So we're going to talk about how to do long division, which you should have learned in 5th grade, but we'll talk about it again, okay?
We know how to do it, it's just...
So I can do pi divided by 3. Pi is about 3.14, right? So I'm going to write 3.14 divided by 3. If you're dividing with decimals, then you need to bring that decimal up here. And then we just do one number at a time. So we go from the left to the right, and we see how many times does 3 go into 3? 1. So I put a 1 at the top, and you multiply. 3 times 1 is 3. So that's what I write. And we subtract, so I get 0, and then I bring down the next number, which is a 1. How many times does 3 go into 1? 0. So I put a 0 up top. So that didn't really work out. So let's bring down the 4. How many times does 3 go into 4? No, sorry. 3 goes into 14. How many times? 4. And 3 times 4 is, so you write down the 12 and you subtract. So you could keep going. I could add another 0, bring it down and make it 20. 6 times gives me 18. So I have 2 left. You'd have to keep going, keep going. It actually ends up repeating because there'll be 6 over and over. So is that, what 2 numbers is that between? 1.046. 1.046. It's between 1 and 2. It's a little bit bigger than 1. So pi over 3 is between 1 and 2 because it's 1.046. Okay, square root of 3. Let's do the same type of thing. We got to find what 2 perfect squares it's between. What 2 perfect squares is it between? So our perfect squares, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Which 2 is it between? 1 and 4. So square root of 1, square root of 4 is what it's between. Guys, what's the square root of 1? 1. Remember, we're asking what number times itself gives me the number in the root. And then what's the square root of 4? 2. 2, because 2 times 2 is 4. So it's between 1 and 2 as well. So I'm going to put square root of 3 as well in that box. And then the last one, okay, if I'm doing the square root of 100 divided by 9, I can split that up into the square root of 100 divided by the square root of 9. What's the square root of 100?
10.
What's the square root of 9?
3.
So you get 10/3. Now, you could write this as an improper fraction. How many times does 3 go into 10?
2. 3.
3 times.
3.
And how many do you have left over?
1.
1. So it's 3 and 1/3. Because 3 times 3 is 9. So you have, goes in 3 times. It gets you 9. You have 1 left over. So 3 1/3. So that's between 3 and 4.